Your mind does not exist where you think it does. I know how that sounds. I don't mean your thoughts are floating in the air, or that consciousness is supernatural, or that your brain doesn't matter. I mean something more unsettling and, in a way, more scientific. Even in physics, the idea of where something exists can be an emergent description, useful, real in practice, but not fundamental. And in a minute, we're going to run into a problem that forces this question on us. Not in neuroscience, in black holes, because black holes did something strange to physics. They took the concept of information, what is true about the system, what could, in principle, be known, and made it behave as if it refuses to live where we expect it to live. And once you see why, the question, where does your mind exist, stops sounding like philosophy and starts sounding like a request for the right coordinate system. Let's start with what we think we know. If we ask a typical person where their mind exists, they point to their head. If we ask a neuroscientist, they might say, in the activity of billions of neurons, in patterns of electrical and chemical signals, in circuits that integrate sensation, memory, attention, and emotion. That's not vague. It's a powerful evidence-backed research program. Damage certain regions and certain abilities reliably change. Stimulate certain networks and experiences shift. The brain is not optional here. So what's the problem? The problem is that in the brain is a location claim. It's a claim about where the thing is. And physics has taught us slowly, reluctantly, that sometimes the best description of a thing is not a little object sitting at a point, but a pattern spread across relationships. Sometimes what you call a thing depends on the level of description you're using. Here's a simple warm-up. Where does the temperature of a cup of coffee exist? You can point to the coffee, sure, but does temperature exist in one molecule? If you zoom in far enough, the idea starts to dissolve. Individual molecules have speeds and energies. Temperature is a summary of a crowd. It's a statistic. It's real, so real. You can burn your tongue, but it isn't located in a single microscopic place. It's not a tiny glowing bead you could pluck out with tweezers. Temperature exists as an emergent property of many moving parts. Now swap temperature with mind, and you can feel the tension already. Maybe the mind isn't a single thing in a single spot. Maybe it's a stable, high-level pattern the brain implements, like temperature is a stable, high-level pattern the molecules implement. But we're going to go deeper than that. Because even if we accept that the mind is a brain-wide pattern, we still tend to assume the pattern is inside the skull in a straightforward way, a local computation happening in local matter, in local space. And that's where modern physics starts whispering. Are you sure space itself is as fundamental as it feels? And let's open a loop we'll come back to. If space turns out to be emergent, if inside and outside are not the deepest categories, then asking where the mind is located might be like asking where the desktop icon exists inside your laptop. The icon is real in the interface, but it's not a little picture sitting in a tiny corner of silicon. Hold that thought. We'll return to it. Now, another thought experiment. Imagine we had a perfect scanner, absurdly advanced, far beyond current technology, that could read every relevant physical detail of your brain. Not just a rough map, but the full physical state at some level. All the patterns that matter for your memories, your personality, your current train of thought. Where would you be in that description? Would you be in one neuron? No. In a specific region? Not exactly. In the whole brain's dynamical state? Closer? But then comes the uncomfortable question, how do we decide what counts as the mind? If the brain is in constant exchange with the body hormones, immune signals, gut-brain communication, do we cut those off? If the brain depends on sensory input to stabilize perception, does the outside world become part of the loop? This isn't mysticism. It's just a recognition that boundaries in complex systems can be somewhat conventional. They're not always drawn by nature with a thick black marker. And then physics adds a twist. Even if you draw a boundary, say the surface of the skull information doesn't always behave like a neatly sealed substance sitting inside. To see why, we need to talk about the weird difference between classical and quantum intuition. In classical physics, information feels local. If I write a sentence in a notebook, the information is in the ink on those pages. If I copy it, now the information is in two places. It's intuitive. Things occupy space, the way objects occupy space. Quantum physics breaks that intuition in a careful, precise way because in quantum systems, correlations can be fundamental. Two particles can be entangled so that the best description of the pair is not this one has its own state and that one has its own state, but together they share a single state. The information about the system can be in the relationship, not in either part alone. That doesn't mean magic signals or mind over matter. It means the bookkeeping of reality can be non-local, in the specific technical sense that the complete information about the whole can't be assigned to independent pieces. And that matters because your brain is made of quantum matter. Now, to be clear, this is important. Most neuroscientists do not think the brain relies on delicate quantum coherence the way a quantum computer does. The brain is warm, wet, noisy, at the scale of neurons firing. When we talk about quantum ideas here, we're not saying consciousness is quantum. That's not an established claim. Instead, the point is subtler. The fundamental laws underneath everything are quantum, and they force physics to rethink what where information is even means. And once that happens, where the mind is becomes a question with multiple layers. Now we're ready for the black hole. Here's the classic setup. You take a book, a real book, with real information, every sentence, every letter. You toss it toward a black hole. From far away, you watch it fall in. At first, nothing seems conceptually strange. The book crosses the horizon, and it's gone. The black hole's mass increases slightly. Fine. But then Stephen Hawking showed something shocking. Black holes are not perfectly black. Quantum effects near the horizon make them radiate. And slowly, over unimaginable timescales, a black hole can evaporate away. So here's the puzzle that set physics on fire for decades. If a black hole evaporates completely, what happens to the information in the book? In quantum mechanics, information is not supposed to be destroyed. The evolution of an isolated system is reversible in a deep sense. If you know the full state now, the laws let you, in principle, reconstruct the past. That's not just a preference, it's built into the structure of the theory. But Hawking's early calculations suggested the radiation is thermal, like random heat apparently carrying no details about the things that fell in. So it looked like this. You throw in a book, wait long enough, and you get back featureless heat. Book to noise. And if information can be destroyed, quantum theory as we know it breaks. Not just in black holes, everywhere. Physicists argued about this for years. And one of the major voices insisting that information must be preserved was Leonard Susskind, who helped push the idea that black hole evaporation must somehow encode the information in the outgoing radiation. But notice what this implies. If the information comes back out, then it was never locked away in the naive way we imagined. Somehow, the horizon, the boundary, must keep track of what fell in. Somehow, the surface of the black hole behaves like a storage device. And that takes us to an even stranger clue, black hole entropy. Entropy is often described as a measure of disorder. But in physics, it's more precise to say it measures how many microscopic states correspond to the same macroscopic appearance. It measures how much hidden information could be inside while looking the same from the outside. So you think if the black hole is a three-dimensional object, its entropy, the number of internal possibilities should scale with its volume. Bigger interior, more room for microstates, more entropy. But Jacob Bekenstein and Hawking found that black hole entropy scales with area, with the surface area of the horizon. Not volume area, that's not a minor detail. It's a flashing neon sign from the universe saying, you are counting the degrees of freedom wrong. It's as if the number of fundamental bits you can pack into a region of space is not proportional to how much space there is inside, but to how much boundary there is around it. Pause and let that sink in, because if that's true, then our usual picture space as a container filled with independent little local pieces might be an approximation. A useful one, but not the deepest one. Here's a simple analogy, and it's not perfect, but it's intuitive. Imagine a 3D object, like a statue, being recorded not by storing every point inside it, but by storing a hologram on a 2D plate. The plate looks flat. The image encoded on it looks like noise. But when you shine the right light, a 3D structure appears. The 3D appearance is real. You can walk around it, see different angles, measure distances, but the underlying storage is on a surface. That's the holographic principle in spirit. The idea that the information content of a volume of space might be fully describable by degrees of freedom living on its boundary. Again, to be careful, this is a profound idea, but applying it to our universe is not straightforward. Physicists treat it as a guiding principle supported by strong evidence in certain models, not as a fully proven statement about every situation. Still, it's hard to ignore how the pieces line up. Black hole information seems to be associated with the horizon, black hole entropy scales with area, and quantum theory insists information is preserved. So now, let's close an open loop. Why did I say black holes would force us to rethink where information lives? Because black holes suggest that what happens inside may be fully encoded on the edge. And if the universe can do that for gravity and spacetime, it raises a new kind of question. When we say something exists in a place, are we talking about fundamental location or an emergent one? Now we take the next rung on the ladder, a proof of concept. There is a specific theoretical framework where the holographic idea becomes sharp and mathematically explicit. It's called ADS CFT, proposed by Juan Maldacena in the late 1990s. Here's the intuition, with no equations. ADS is a kind of space-time anti-de Sitter space that has a boundary of infinity. It's not our universe's exact geometry. Our universe seems closer to de Sitter-like expansion due to dark energy, not ADS. So we have to be honest, ADS CFT is not a direct map of our cosmos, but it's a laboratory model where we can test an idea. CFT is a quantum field theory, living on that boundary. No gravity in the usual sense, just quantum fields. And the astonishing claim is these two descriptions are equivalent. The gravitational world in the bulk spacetime can be fully described by the quantum theory on the boundary, not approximately. In the model, they are two languages describing the same physics, like two different file formats for the same movie. In one format, it looks like a story happening in a 3D world with gravity. In the other, it looks like a quantum system without gravity living on a lower dimensional boundary. If that's true, and in this context, it's one of the best understood ideas in theoretical physics, then space is not necessarily fundamental. The bulk direction, the depth, can emerge from patterns in the boundary theory. So the where of something in the bulk could be a derived concept, something you compute from more basic ingredients. This is where the mind question becomes sharper, because we usually imagine the mind as a thing happening at locations in space. Neurons here, signals there, circuits in this region, dynamics in that region. But if location in space itself is an emergent concept in some deep descriptions of reality, then the deepest answer to where does the mind exist might not be in the skull in the way we usually mean. Let's be very clear again. This does not mean your thoughts are secretly written on the edge of the universe, or that your consciousness is a cosmic boundary phenomenon. That would be a leap far beyond evidence. What it means is something more disciplined. The concept of where can be level dependent. At one level, where is the right question. At a deeper level, the fundamental description might be in terms of relationships, correlations, and information structures from which the notion of space is reconstructed. Now we return to the earlier analogy, the desktop icon. When you drag a file into a folder on your screen, where does the file go? In the user interface, it moves to a location. That location is meaningful. It predicts what you'll see next, what happens when you click. It's real in the world you interact with. But underneath, the file is patterns of charge in memory cells, magnetization on a disk, error-correcting codes, distributed redundancy. It's not in the top right corner. That's an emergent coordinate system designed for a certain kind of creature, you. Here's the key framing. Emergent does not mean fake. A hurricane is emergent. It's not a new fundamental particle, but you don't want to stand in it. A market economy is emergent. It's not in any one person's wallet, but it shapes lives. A melody is emergent. It's not in one note, but it's real. So if the mind is emergent, that doesn't demote it. It locates it correctly as a higher level pattern that is stable, predictive, and causally powerful in its own domain. Now we can build a careful emergence map from physics to mind. At the deepest level we know, the world is quantum. The most fundamental description uses states and their evolution, and the way subsystems are correlated. From that quantum description, we often recover a classical world, objects with positions, trajectories, and approximate independence. That recovery is not automatic. It depends on decoherence, environment, and the fact that certain macroscopic patterns become robust. From that classical-ish world, chemistry emerges, stable atoms, molecules, reactions. From chemistry, biology emerges, metabolism, self-repair, evolution. From biology, nervous systems emerge, control, prediction, learning. From nervous systems, brains emerge, layered models of the world, memory, language, social cognition. And from brains, minds emerge, the lived interface experience, attention, intention, self-models. At each rung, the new description is not an illusion, it's a compression, it's a way of talking that captures what matters at that scale. Now here's the twist that connects back to holography. In some areas of physics, the container space-time itself might be part of what emerges. So the mind would be emergent in two senses. First, emergent from neurons and biology. Second, and more speculative, emergent within an emergent space-time, meaning that where the mind is located could itself be a useful story rather than the ultimate ledger. To make this vivid, consider a different question. Where does a wave exist in a stadium? If thousands of people stand and sit in sequence, a wave travels around the arena. You can point to its location, you can measure its speed, you can predict where it will be. But the wave is not an extra object floating above the crowd. It exists as a pattern in coordinated behavior distributed across many individuals. If you freeze time and look for the wave particle, you won't find it. You'll find people, each obeying simple rules. Your mind, in the most grounded scientific view, is like that, a dynamic pattern in physical matter. Now add the holographic flavor. What if the most fundamental people in the crowd are not arranged in space the way we think? What if space is the thing that emerges when the underlying degrees of freedom correlate in the right way? Then where is the wave is still a good question at the stadium level, but it's not a fundamental question about the deepest description of the crowd. And that's the core answer carefully phrased to the title question. Where does your mind actually exist? At the level of everyday life and neuroscience, it exists as a process implemented by the brain and body, unfolding in physical time, localized enough that injuries, drugs, stimulation, and development matter in specific ways. At a deeper theoretical level, what localization means may be derivative. The mind could be a stable informational pattern, and where it is could be a coordinate in an emergent geometry rather than a primitive fact. Now, before we end, let's close one more open loop. I hinted that this changes how we think about the Big Bang. In some holographic ideas, again, speculative when applied to our universe, the Big Bang might not be best pictured as a point exploding into space, like fireworks from a center. It might be better understood as a boundary condition, a special state in a more fundamental description from which space-time itself emerges. That doesn't mean the Big Bang didn't happen. It means our mental image and explosion into pre-existing space could be the wrong interface. And if our mental image of the universe's beginning can be an interface story, then our mental image of where the mind sits might also be an interface story. Useful, accurate in practice, not ultimate. So what are the implications of thinking this way? First, it shifts the question from where is the mind located to what physical pattern is the mind? That's a more scientific question. It invites measurement, modeling, and prediction. It also explains why the mind can be robust even though its components are constantly changing. The pattern persists even as the particles come and go, like a whirlpool that stays while water molecules swap out. Second, it reframes identity in a way that's both empowering and unsettling. If you are a pattern, then what matters is not the exact atoms, but the organization and continuity of the process that aligns with what biology already suggests. Your body replaces much of its material over time, yet you remain you. But it also raises hard questions about copying, duplication, and what would count as survival if an identical pattern were created elsewhere. Physics doesn't settle those questions, it just sharpens them. Third, it changes how we think about boundaries, skin, skull, and even horizons. Boundaries can be places where information is encoded and protected, not just walls that separate inside from outside. In black holes, the horizon behaves like that boundary. In brains, we don't have anything like a literal event horizon, but we do have layers of representation and compression, where the brain builds a world model that is not the world itself, but a boundary-like interface between the organism and reality. And now we can finally say the provocative claim in a more mature way. Your mind exists where the pattern exists. And where is not always the deepest question in your life. It's fair to say your mind is in your head, because that's the level at which cause and effect is tracked. Injury here changes experience there. Stimulation here evokes memory there. But in the deeper accounting that physics hints at through black holes, area laws, and holographic dualities, the universe may not store reality the way our intuition expects. The inside may be encoded on an edge. Space may be reconstructed from information. And location may be a property that emerges, not a property that dictates. Physicists like Hawking, Susskind, and Maldacena didn't set out to answer questions about consciousness. They were trying to save the consistency of physics. But in the process, they gave us something unexpected, a new way to think about what it means for anything to exist somewhere. So here's the final thought. If the mind is emergent, it is not less real. It is real the way waves are real, the way temperature is real, the way a storm is real, the way a story is real. Not fundamental like an electron, but not imaginary either. And maybe the most honest answer to where does your mind actually exist is this. It exists as a living, self-updating model implemented by matter, constrained by physics, and grounded in information. The place you feel it behind your eyes, inside your skull, is the interface your brain uses to make that model usable. If you want more documentaries that connect modern physics to the deepest everyday questions without equations, but without dumbing anything down, subscribe. And I want to leave you with one question to answer in the comments, because it cuts straight to the heart of all of this. If you are a pattern, what do you think makes that pattern truly you continuity over time? The specific memories, the body it runs on, or something else entirely?